Hello everyone, and welcome in this new DevLog session. So we are at DevLog number 16 this time, and yeah, there was quite a lot of stuff going on in this one, and well, this was mostly focusing on adding support for Emscripten and compilation with the EMCC compiler, and trying to build some initial symbols with that. So let's go and start reviewing all those points together, and we'll see where we need to talk and provide some additional details compared to what I've been writing here. So first thing was, well, wait a second. Before that, in the previous devlog, we were already preparing the EM SDK, so we prepare a manager for that. So we have this manager in NervProj actually. Probably the core folder, this one. I'm not sure what was already there or not, but the latest thing I've been adding on this one was the support to automatically install the EM SDK if it's not available when you try to get access to the EMCC compiler. So this was already in place, but what was missing is this part, so it was not really working before, but now it seems to be working. It should be working fine. I mean, hopefully. I'm not quite sure actually. So yeah, this was probably already in place from the previous devlog. Not much more to say about that. But really, when I started on this one, the first thing I was trying to do was to try to compile a simple library like the zlib library. And yeah, there was a few issues on this one as far as I remember. Where is that? But from the ground, the idea was really to try to use the builder system that we have in place and try to use the existing command to build with cmake and make. So at first it was not really done this way. As we have reported here, I was manually first trying to patch a file, then I had created the emcmake command to run this Emscripten specific version of it, of cmake. Well, it's not really a specific version of cmake, it's just that it's a specific bat file and you're going to pass a cmake command to it. And then we were running Ninja on top of that. The thing is, zlib is actually going to build a shared and a static library. And when you do the configuration with emcmake, it's going to prevent you from building a shared library, and it's basically going to ignore the shared requirement and still build a static library instead. But yeah, when we do that, by default you would output the library for both the shared version and the static version of it, which is making Ninja pretty unhappy actually. It's going to refuse to build because it's going to tell you that, okay, this one is called Z and it's building the static library with Z, and this one, which is supposed to be the shared version, but it's going to be the going to build a static version or anyway with emcmake, so it's going to use the same name, and so you're going to build the same library twice. So it doesn't want to do it. That's why we had to patch the file initially to ensure that we produce different name for the outputs. That was then working. It would then build a static library, and I think, yeah, also building this one, which is also another static library, but basically it was the same thing, I think. Then we did the same processing on Linux, except that on Linux it's a bit easier because you can just run make instead of Ninja, and make doesn't really care if you're generating twice the same static library name, and you can just run the command without patching any kind of file. What did I try next? Yeah, I was also adding support for GNU make on Windows. So where is this done? I think it's again in the nervproj config file as part of the tools, probably. Yeah, that's probably it. So we're going to install make now, which means that then you can also run make from Windows. I decided to do that because, as explained, Ninja can be a bit, well, too strict in this case, for instance, so it would be handy if you could have access to make. So I was adding that. Then, yeah, you have to, of course, make sure that make is found on your path. So we're going to customize the builders to ensure that the path to make is added to the environment when you are about to build. So we have that. In the builder, I believe, at the start, yes. When you're preparing a builder, it's going to ensure that make is made available. Okay, and so with that change, we could then run this command on Windows to generate the building for still for the Z library here. And you were first executing just em make command, and then well, implicitly this is going to provide a list containing just make, and otherwise I'm overriding this list. I was overriding this list and specifying that I want to do the installation part. So yeah, that was cool, was working, but I didn't really want to stick with using specific commands like that when I am on the EMCC compiler. It would be much more handy if I could just keep using CMake and make and Ninja and everything, and it would just call the EM version of it under the hood. So that's why I decided to update the command that I have. So for instance, when I'm going to run make now, I'm going to prepare everything as usual, but also going to check what is the current compiler, and if it's EMCC, then you want to in fact prepend the em-make executable on the command line. So this is in fact what you're going to execute instead of the default make command. And we do that for em configure, for the configure command, the make command, and the cmake command in the builder. So if we have a look now, we have, it's not applicable for nmake because that doesn't make sense. For Ninja, it's interesting. You can run em-make Ninja. Maybe. I guess I've tried that. It's working. So why not? So yes, we're doing that here for Ninja. For run ninja, it's going to call exact ninja anyway. For exact make, we're going to do that also. By default, you just try to run make, but if you are on the EMCC compiler, you're going to use EMMake instead. What else? CMake also. So if you have this compiler, you use this command. And as I said, for configure, we do the same thing, which means that now in the builder itself, we don't really need to have those run em cmake or run em make or whatever. This is fully integrated into the default run commands. So after that change, yeah, we could get back to simple commands like this one to do the building of zlib. And this is the final version that we're currently using. So we have that as demonstrated here. We run cmake, which is going to call emcmake, generate makefiles, and you just run make, which is going to call emMake. And that is going to use a GNU make installation on Windows. So we don't need to patch anything. On Linux, we do the same thing, except that we generate Unix makefiles, and it's working just the same way. So this was really the first attempt I did to try to build a library with the EMCC compiler. Took some energy and some trial and fixing, but yeah, in the end it was pretty easy to get this working. And so I've been continuing after that to try to build some additional libraries which seem to be well, relatively simple. Started, for instance, with YAML CPP, and for this one I didn't have to change anything. The default builder was working just fine. So in this one, what we were doing, just specifying that we didn't want to build the shared libraries anyway, so this was turned off already. Then we run cmake, so recall that this is calling emcmake under the hood, and ninja, and that was working fine, producing the EMCC libraries. Actually, if we go, I think, okay, wait a sec. Yeah, so if we go in the Nerv project, in the libraries, we now have this Windows EMCC folder, and in there we have all the libraries that we have compiled, or maybe not really compiled. Well, I'll come to this point a bit later, but if you check, for instance, YAML CPP, you see we have the include folder, which is regular include folder, and the lib folder where we have this static library, which is the, well, WebAssembly compatible build static library. So we can use that then to build a WebAssembly package or module or whatever. So this is cool. Next up, OpenSSL was also pretty straightforward to build. We just need to disable a few things, and so no ASM, which makes sense. You don't want to build assembly, use assembly code when you're trying to build for WebAssembly, because this assembly is designed to work for x86 or something like that. So not good. No shared version, no hardware acceleration or stuff like that, I guess. No engine, I'm not sure what this means, but well, it's visible in the example code that I found, so I try to keep that visible also. And then you prepare your configuration command, which we'll call emconfigure, providing those flags. And also, yeah, that's a small feature that I added by default. When you execute the configuration command, you're expecting to have a configure file, which is a starting point script. But for OpenSSL, this file is rather called config. So we can now override this file name, and you'll be using config here instead of the default version, which is configure. So you do the configuration step. Oh yeah, we had to do some fix of this cross-compile variable in the generated make file. As far as I remember, it was a bit mixed in the result, and it was basically duplicating this part of the path or something like that. So instead, okay, you're getting the make file, and first yeah, I mean, cross-compile is a prefix that is going to be added on your actual compiler path. So you don't want to add that. So I just tried to set this to an empty string, because then your actual compiler will already provide a full path. That's why this full path was basically duplicated. And then you can run make and then install software. This was again working fine and produced the installation for OpenSSL, which you had there. Also the library part. I mean, binary. What do you have? I don't know what these are. This could possibly be actual binaries. Maybe these are JavaScript files. We could have a look here. Oh, Perl files. This one is JavaScript, which is really fun and amazing. I didn't try to run that at all, but I would not be surprised if it would be working just out of the box like that. But anyway, we're not really interested in the binaries. The only thing we need to mention maybe is that the library part is called libx32. And in there you have your crypto.a and SSL.a. So again, a pretty easy build process in the end. For OpenJPEG, minor change to avoid building the shared library. So you just set you disable the building and that's it. LibPNG, you need to do the same thing. PNG shared set to off. And when I was done with those simple libraries, I was starting to build confidence that I could maybe try to tackle something a bit bigger. And I went for QT6.4 directly. So yeah, this one, I was expecting this to be, in fact, significantly more complex. But again, in the end, it went pretty smoothly. And so what did I do in there? I think, yeah, I basically prepared an additional function to do the building with the EMCC library on Windows. I'm not sure I'm building that on Linux yet, but yeah, it's probably going to work just fine on Linux. Usually it's more complex to set everything up on Linux, on the Windows, sorry. So if we go and check this builder, so when you call this on Windows, first thing you do is check if you are using the EMCC compiler, and if it's the case, then you are going to delegate everything to this function call. So that's a new function that we have created. because otherwise on Windows, yeah, we were actually trying to move everything concerning Qt in a base folder, so you could avoid too long paths when doing the compilation on Windows of the web engine module. Except that for the EMCC compiler, we don't really want to do the compilation of the web engine, Qt web engine, so I'm actually skipping this part. So it doesn't really make sense to consider this moving of the sources and all, so it's simplifying the build process a bit. So yeah, you need also access to an host version of Qt, which means we need to have the CLang or EMCC version installed first. I went for the CLang version here, which is used at host version. Then you provide this host path. You have additional settings like platform being WebAssembly and Emscripten. Then usual stuff. Yeah, I think this one is going to disable the threads by default, but it was mentioned in the Qt documentation that you can re-enable them by specifying feature thread. Also, you want to have static. I'm not sure. I think it's also specified by this one, but yeah, it doesn't hurt to just have it here in case it's not true. Then, as I said, I'm disabling web engine anyway, because from my perspective, it doesn't really make sense to try to build web engine for something you want to run on the web. Sounds weird. Qt Quick 3D is this one, was not building successfully as far as I remember, so I tried to disable that one, which means you also need to disable the physics module here. Apart from that, you need to have the toolchain file. I think in the builder themselves we are providing that. Not quite. Really? I'm not specifying that. Okay, I guess that's going to be specified with EMCMake automatically somehow, because everything is working fine at the end. So, but here anyway, you are going to call CMake a bit more directly, so you need to have those arguments provided for CMake. Then generate Qt config is a function that I have extracted from all the build functions here. So you have that for all the compilers, in fact, so it's called multiple times. You have the first version for EMCC, but it's also called when you are building with what is supposed to be the compiler here. Otherwise, I think it's just supposed to be, okay, if it's CLang, it's going to throw an error anyway, but otherwise you are using MSVC on Windows, and on Linux it's also called for CLang this time. So yeah, then what do we do? You have the actual configuration command, or post configuration command. That's how I called it, because first you generate this config in opt file, which is your input for the next step. And yeah, you process config args. You still need access to Perl, I believe, and I'm not quite sure about the other ones, but I just provided that anyway. I didn't need to provide access to Python or Node.js, which kind of makes sense because I believe those are only used for the web engine build. And yeah, remember that we have disabled this part here. And that's it, because then you can just go with some kind of regular build. In fact, regular build using really CMake itself to do the build. We don't have to deal with EMCMake here. Because yeah, I guess probably because we are already providing that anyway. And so yeah, you just do the build process and the installation process, and boom, that's it. It's working just fine out of the box. I didn't get any significant error as far as I remember. And you have your QT6 library generated like that. So you have your lib folder with a few static libraries. It's way smaller than the corresponding CLang or MSVC version of it. I think the compressed package is only like 32 megabyte or something like that. But well, I believe we should have everything we need in there. Thing is, I have not really started testing this part, so we'll get to this shortly. But yeah, so this is it for the QT 6.4 build process. Oh yeah, also in this on this page you can find a list of the modules from Qt that are really supposed to be working with WebAssembly, and the list of modules that are not really tested either. So if we just have a look at that. Okay, Qt 6.5, not really the same version anymore, but never mind. That's also where I found some of those indications on what to do exactly to do the building, but I drifted a bit away from this build process, but it's still working fine. Running application, I'm not really doing it yet, so we'll see. And yeah, supported browser, not quite sure if I need to care about that yet. And this is a list I mentioned for the modules that are really supported on this platform. Those are, well, in process. Yeah, technology preview. And yeah, this is worth reading also, I guess, but we don't really need to spend too much time on that. So this was it for Qt. Then what did I do? Yeah, for long before that, in fact, I was always using a dependency on Boost in the Nervland project. But if you consider the evolution of the C++ standards lately, basically everything I was using from Boost was available now directly from the C++ runtime, so I didn't really need to use Boost anymore, so I've been removing all those requirements, except for the testing part, because when it comes to running the unit test, so those tests here, I'm still relying on the Boost testing framework, which, well, I find convenient anyway. So yeah, still using that. Also, while doing that, I realized that I'm basically already using C++20, and I don't remember where exactly, but at some point I was wondering how I could avoid specifying a default value for some parameters in C++ function when I only want to specify one of the parameters that is at the end of a list, for instance, and I have default value for a lot of parameters. And in fact, this is already available in C++20. So that's what we call the named arguments. So I could start using that. It's just that I have not been using it so far. Anyway, after this step, I thought it was a good time to start trying compiling the Nervland project itself with Emscripten. So first step was to prepare this set configure compiler flags function, which is a CMake function which I'm using to figure out what is the current compiler that I'm using. So this is defining the macro folder here, macro file, and so this is going to cache different Boolean values which I'm using then to figure out what is the current compiler. So it depends, it's using the CMake compiler ID, but in the case of Emscripten, actually we need to do a bit of a hack to update this value. Otherwise, I think it's going to just consider that it's using CNAG. So you need to do this. And that's it. Then with that I can use simply is MSVC, is CLang, or is Emscripten, which I'm using a lot then in the configuration file. So for instance, if we have a look at the main CMake list file, we will have a statement like this one. If we are on Emscripten, then you do something specific. Then if you're on Windows, you do that, and otherwise you do something else. For instance, when it comes to building in the sources folder, you have those two projects that are going to be built anyway, and all the other project you are only going to build that if you're not on Emscripten. Alright, also for the test, I think currently you don't have any test at all if you are on Emscripten. So yeah, at this point I had to start preparing some Doomy packages because the CMake manager that I have provided in NervProj is still expecting to have the boost dependency, whatever is your compiler for this project. So because we are specifying that in the project settings, so this is in the nv-config file here. We have the dependencies here, and we say that okay, we have dependency on boost, so it's really expecting to have the boost library built for EMCC, but I didn't want to go into this build process at all. So what I did was simply to provide an empty folder, and we have those 3 subfolders, and I just prepared a package with that. So for now, yeah, this is a Doomy dependency package, and I have that for a few additional elements like GLSLang, for instance, or Lua GIT most probably. Yeah, it's not possible actually to build Lua GIT on Emscripten. I think, yeah, maybe I mentioned that a bit later. We need to compile the FMT library. Okay, no change needed. For Lua GIT, I thought maybe we could disable the GIT part. I've read a few comments online that mention that it should be possible to do it if you disable GIT part. But yeah, that was a bit tricky, didn't get it to work, and I didn't want to really insist on that direction, so I just gave up. Yeah, in the end I just provided a Doomy package for Lua GIT, which also means that in the NV core package, and in fact in the complete and the complete system, I mean ND core and NervSeed, I'm providing some way to ignore completely everything that is Lua related when building with Emscripten. In the end, that is not really a big change because all we have to do is, I think it's in there in the source, in the CMake list file here. You're going to retrieve all the sources from your source folder, so header file or CPP files, and then if you're on Emscripten, you're simply going to ignore all the files that you have in this folder. So we just remove them from the list of source files. And apart from that, the only real location where we are trying to access Lua related stuff is in the Nerv app CPP file. So here you were basically trying to initialize the Lua manager. So this is disabled now if we are on Emscripten, and there are a few additional locations where we had to disable that part. Okay, this was something else, we'll get back to it. And this was, for instance, something Lua related, so you don't do the initialization of the Lua manager at all. You don't do the uninitialization either, or yeah, the destruction of the manager here. And yeah, just then final change in the core command file, we don't include anything that is Lua related here either. And with that, you could build the NV core module, static version of it, for Emscripten, I think. Oh, not quite. Before that, I also had to update the SDL2 library because when we were trying to build with this version, it was not building, but you could upgrade to this version, and after that it was just okay. And I have tested obviously with C9 and MSVC, and the test application was still working fine, so nothing to change, and it was just a drop-in replacement. Okay, I guess I had to do some updates on the code itself to ensure we could still compile everything with MSVC. Same thing for Linux. I remember this one was a bit tricky also. I started to ask myself a few questions concerning, yeah, really the STD C++ standard library and mixing stuff between GCC headers and C9 headers. In the end, I think I'm currently using Clang as compiler on Linux, but still rather accessing the GCC headers, because Clang is going to use a specific C++ library, and when I'm using this one, I could not figure out how to use it properly because it's still, yeah, complaining that we have missing header files, and I tried a few different things and I could not really set this up properly. So for now I'm just, yeah, not trying to update this part and just using what I have already working, which is, as I said, using in fact GCC headers. But that's probably okay for now. The only minor thing I had to kind of disable for now is this bool vector that I am creating, because there's some kind of optimization used in the headers from GCC, and when it comes to build a vector of bools, it's going to actually use a, well, pretty specific implementation where the bool data can be stored on different bits. So you can't really build that in an automatic way as I was doing in the bindings. But anyway, after that, I just prepared additional dummy packages, as I said, for those three packages. I was compiling OpenSSL on Linux but I just took this copy from Linux and just pretend that I was building that on Windows also anyway, and make another package with that. Building libcurl worked without any serious issue. Some minor update in the libcurl builder. Let's see, what did I do in there? So builder for libcurl. Yeah, I remember I had to specify a few of those additional paths on Linux, and same thing on Windows here. Yeah, stuff like that. And actually, this library I was first building on Windows, but I also then tried to build it on Linux, the EMCC version, and both builds went just fine. So yeah, we have this libcurl package, and then another Doomy package for libuv, which I'm using only as an input for one of the Lua bindings. Lua modules that I'm using. But since all the Lua modules are visible for Emscripten, it just doesn't matter at all, so we don't need that. Then I was trying to compile the NV core module again. For Emscripten, of course, we have to build the static version of it. So I just modified the CMake files to ensure that we go into the static folder. Then there were a few changes to make. For instance, in the spin lock function, we can't really use those intrinsic functions. So I just commented this part, remove that for Emscripten, and then the building is working fine, and I don't think that this part is critical. Maybe it's critical, but I've seen other implementation of spin locks that are not using it, so I think it's going to be suboptimal, but still working, I guess. I don't really remember what this is doing. Without generating cache misses. Yes. So we're going to get cache misses. Maybe something to look into later. Also, we had to check to ensure we were only compiling for 64-bit architectures, but it turned out that Emscripten, when it's going to generate WebAssembly packages, it's going to just generate WebAssembly 32-bit architecture packages. I think we have ways to configure this now to build 64-bit WebAssembly packages, but I didn't look into that yet. So for now, I'm just using the default 32-bit version, and it's just fine to disable that. Everything else was still building just fine, so okay for now. As I said, then yeah, I had to remove all the references to Lua from the NV core package, and that was mainly in the nerv app file. And finally, then I could build this NV core static library. Question, I was wondering if we could maybe run a WebAssembly package directly on Android phones. But yeah, result of this investigation is that, yeah, could be possible, but sounds still to be pretty tricky. You have to build this runtime thing yourself, and you have to install that manually on your phone or something like that. It was pretty intimidating, so I didn't go much further than that. We'll come back to this question maybe later, we'll see. And then some minor additional changes to be able to build the NervSeed app itself. Let's have a look at this one. So NervSeed, there's not much happening here, it's just the main file that we have here. But this one was going to try to execute a Lua file. So I'm for now just disabling this part again, so we don't have anything to do with Lua. And we're just going to simply try to run the default construction of the Nerv app and not doing anything more than that. Then you're going to destroy it, destroy the memory manager, and just exit the application. That's it. So basically, we're not doing anything in there, but this is just for testing for now. One thing I had to change after that is also in the configuration part of the project, where we have, let me find that, yeah, a list of different dependencies. For instance, for Windows, we were trying to install a lot of those dependencies. Same thing for Linux. But now for WebAssembly, since everything is going to be built as static libraries, you basically don't have anything to install for now. But I still provided Emscripten dep module entry, or at least support for this entry in the, no, don't want to do that, in the CMake manager. So we should have Emscripten, yeah. If we are on this compiler, then you change the platform to this Emscripten name, and you are going to install the dependency module corresponding to this. If we don't have anything specified in there, then you don't have anything to install. But before that, it was simply going to try to use the Windows dep modules, which was failing actually, because it could not find those libraries, those dynamic libraries for the EMCC compiler. So this change was required anyway. Okay, what else? Yeah, then we had to figure out how to generate the HTML file, because by default it's just going to generate the JavaScript and WebAssembly files. So, and how to install them also, because again, we are building in a different folder and we wanted to get that into the Nervland test web folder in there. So this was updated in the CMake folder that we have for NervSeed, and also part of it was done in the main CMake folder, because when we are on Emscripten, yeah, you need this specification. You need to change the suffix of your executable, and this is going to tell the compiler that you want to add the HTML file generated also. Maybe I'm not going to keep that very long, we'll see, but as a starting point it's pretty handy, because then you can just run this file in your browser and well, check that everything is working. So as said, yeah, the first change was in this file, but then also in the sources NervSeed here. We'll get back to this part. What did I change? For the installation part, that's how you specify that you have different files that you want to install. The JavaScript file, WebAssembly, HTML, and later I also had to add this data file. I think that this is the next point actually. So first, yeah, we were just starting those three files. I did a few tests, in fact, with that. Loading this application on my own web server, and it was starting to work. but eventually produce a crash or JavaScript exception, in fact. And this was because one of the first things we're going to do in the Nerve app is going to be to set up this application. So the first thing is here, when you try to get an absolute path from the executable path, that's going to be not working by default in Emscripten, but I've fixed this implementation now because I'm specifying a default, a custom processing for Emscripten here. Wait a second, executable path. Maybe this is something I should change. I was also trying that at first because I've asked ChatGPT what should be done here, and it told me to do that, but that's not working, so not so good. But anyway, I thought, yeah, we really don't care here, and we can just use the local folder as a hub path. Except that now that I'm thinking again about this, eventually I decided to go with this kind of path. So yeah, probably this is what we should return also here. But since we're not calling this for now, it's not going to really matter. Anyway, I have then updated the call here to just specify an hard-coded root path. And after that, when you do the loading of the configuration, we're going to try to access this config YAML file, which we have in the disk folder. So we have this config file with our initial configuration for the GitHub module, if you remember. And first, when running the application from the web server, it was complaining that this file could not be loaded because it was not found. So that's where I had to figure out how to provide this file with Emscripten. So this is how we're doing it now. So we have this part, in fact, again in the CMake file for the WebAssembly app. So let's get back to this file. Sources here. So it's this part. What we're going to do now is to specify a list of assets that are supposed to be in this folder here. So we could also have relative path inside there, but currently we're only concerned about this file anyway. So what we do then is we figure out what is the installation folder, which is this folder, in fact. And we're going to build a command line. So to build this command line, we just add one by one for all those asset files, the preload file. This is the location where the file is, and this is the location where we're going to store it in the virtual Emscripten file system. So with this command line, which is a large string, we're going to write a file. This is coming from, I don't know, I've copied that from somewhere, but I didn't keep a reference of it. But anyway, the idea is you want to store this command line in a file because it can become pretty long here with all those preload files if you have a lot of assets. So you don't want to provide all of them in the command line directly. It's better to store them in a file and then specify this file on the command line. And yeah, that's it. That's how you actually provide access. Then you set those link flags on your target that is supposed to be built. And with that, your config file will be in the virtual file system, and it's going to be found here. In fact, I was then trying to read the content of this file and displaying this content before actually reading it as a YAML file, and I could indeed see this content displayed. For your information, this content is completely stored in this data file as text, as far as I understand, because if we have a look at it, web data, you see that this is just the content of my YAML file. So I have no idea yet how Emscripten is going to, well, figure out where is the beginning of the file, where is the end of it, when you have multiple data for your assets. So we'll see. Not really a concern for now. And this is it, because then I can build. I've done that just above. If I make a modification, for instance, in I've already done that. I made a modification on the get executable path in there, so it's going to rebuild. So if you do the building now, we have a few warnings like that, but I don't think that this is related to Emscripten itself. And then when you're done building, it's going to install your files in there. What I've tried to do next was to copy those files. Let's see, I'll make a modification, for instance, in the main file. Or let's do that, yeah, in there. So let's say nerv app config content is okay, and next I need to do the copy. So this is a folder where I have the data for my website stored, so I can just take all those files, copy them on this location, replacing everything. And next, if I go in there and I try http nervtech.org tester, that's a cached version of it. Oh no, not even. It was pretty fast, so I thought it was cached, but yeah, that's because I have a local connection here. I was trying with another computer on a different getaway where it's taking a bit more time, so that was the reason why I'm used to slower response. But as you can see now, we have everything in place. It's displaying this hello world from where? It's from the main file here. The first statement that we have is this hello world. Then creating log manager and everything, loading the config file from this path, then displaying the content. Then it's actually doing the loading of that config, and eventually we're done, and we can just exit the application properly. So that's really cool, and it's working pretty fine. And this is it for this review concerning this devlog. The next major step I think that I'm going to take now is to try to do some test with the Qt library to see if I can display some kind of window or something like that, and start manipulating buttons, labels, and more. So this will be for the next devlog. So thank you very much for watching this, and see you next time then. Bye bye.